So in Audacity, we can generate tones. We're going to generate a sine wave of, let's start with a 440 Hz frequency with an amplitude of half the maximum, 0.5 of the maximum possible amplitude, because we're going to add other waves to this to see how addition of waves works and how that influences the sounds. So we'll generate that tone and we can listen. That's our tone. So I need another track on which to generate an additional tone. We'll make this twice that frequency as an example, and there will be less of a contribution. Let's make it 0.3. Generate the tone, and there we are. We can mute the first and listen to the second. There it is. And then we want to add a final track, and we're going to generate a tone which is 3 times 440. That'll give us 1320 Hz. And just a minor contribution, 0.1. So in total this will give 0.5 and 0.3, and 0.1 is 0.9 of the maximal. So we generate the tone, and again we can mute the others, listen to that, that's our tone. Now, we can listen to what all three sound like together, but what we want to do is show how that is reflected in the waveform. To do that, I need to quick mix that will add all these waves together to form one single wave. So this is what it sounds like, as we've just heard. And now if we zoom in, we'll see that the waveform is in fact quite different. The shape is different because of the way we have added the waves together. Now, we can also analyse this by looking at the spectrum, and this is where Audacity has figured out, using some clever maths called the Fourier transform, it figures out that we have a main contribution of 452 Hz, not far from 440. The next one is 887, very close to 880, and the final one is 1324 Hz, as seen down here. So, Audacity is a powerful tool to manipulate sounds, and it allows us to see how different shapes of waves can be made by addition of multiples of the base frequency.